Lots of vocab, and we talked about it, and we talked about some of it. I showed you in a video at the end of class on Wednesday. So you should have seen some of this vocabulary before. We're going to talk about different pairs of angles and the things that we can say about those types of angles. These are going to be useful to us. You shouldn't need to write these down. They should be here. So when I go to check the notes, you should have a packet that has the first 2 pages, and it should be filled out for you. And the last 2 pages have all the examples on them. And so I'm not going to be checking those first 2 pages that just has the vocab. I'm going to be checking the pages that have the actual examples on them. That's what I'm going to be looking for. So let's start with our vocab. A couple different terms to start with. First is adjacent angles. Adjacent angles are angles that share a common side. Another way to say that the angles are adjacent is that the angles are touching. That's another way to say adjacent angles. Angles that are touching, they share a side. So ABC and CBD, these 2 angles right here, are adjacent angles because they are touching. They share a common side, which is the B to C. That one in blue would be the common side that they share. So that just means that the angles are right next to each other, that they're touching. It doesn't say anything about their measurements or anything else. It just says where they are in the diagram. The next couple that I'm going to show you are talking about measurements. So let's look at those. The main ones we're going to start looking at are complementary and supplementary, because these 2 are tied very close together. They're very much related to each other. If 2 angles are complementary, then their sum is 90 degrees. So sum, remember, means addition. So complementary angles are 2 angles whose measurements are 90 degrees. So these 2 angles are complementary because if I add them together, this one's 60 and this one's 30, if I add those together, they make 90. Angle 1 and angle 2 are complementary because if I take these 2 angles and put them together, then they make a right angle, which is 90 degrees. Pair of angles do not have to be adjacent. All that needs to happen is if I take the 2 angles and add them together, then they need to make 90. Supplementary, 2 angles being supplementary means that they should add to 180 degrees. So supplementary angles are a pair of angles that add to 180. This is why I said that we're looking at pairs of angles. Pairs of angles. Because we already have a word for example, we just said 2 angles add to 90 are complementary. But we already have a word for if an angle is 90 degrees. What's our word for an angle that's 90 degrees? Right angle. So a right angle is an angle that measures 90 degrees. So complementary doesn't just mean 90. It means that we have a pair of angles that add to 90. Supplementary means that we have a pair of angles that add to 180. So keep in mind that you have to have 2 angles to make a pair of complementary or supplementary. We don't talk about a complementary angle. If you're trying to say that, then you should say a right angle instead. Complementary or supplementary are for pairs of angles, two angles that when I add them together make 90. Two angles that when I add them together make 180 for supplementary. So let's start with those terms. First off, any two angles that are next to each other, so these two angles, these two angles, these two angles, are adjacent. They're touching. They're right next to each other in the diagram. But if I'm interested in complementary and supplementary, then I'm interested in what are their measurements adding to. So see if you can pick out which angles are complementary, which angles are supplementary. And then I want an example of neither as well. One way, if you look back at the video with the vocab, one way that they said is good to keep track of complementary and supplementary and tell them apart is that in the alphabet, C is going to come before S. So complementary comes before supplementary. Complementary comes first, so it's the one that adds to 90. Supplementary comes second, it's the one that adds to 180. C comes before S in the alphabet. That tells us complementary is the one that adds to 90. Supplementary is the one that adds to 180. This is also a practice with being able to name our angles. Because I don't just want the numbers, I want how we would name those angles. How would we label them? So that's part of what you're practicing. And then we should be able to check it by our actual measurements. For complementary, I'll give you complementary. We have angle ABF and angle FBE. So let me show those in the diagram. Remember, this traces out the angle, vertex in the middle. Vertex, the point that the angle originates and comes out from, in the middle. So ABF is A into B, out through F. So that's 60 degrees. Then we have angle FBE. F into B, out through E. That's 30 degrees. 30 and 60. Oh, it's 90. That's why they're complementary, because when I take the angles, add them together, they add the 90 degrees. Supplementary. I have angle ABC. This is for you to check your work. And angle CBD. What does angle ABC measure? A to B out through C. What's its measurement? 128. Then CBD, 52. C to B out through D. I take 128 and 52, and lo and behold, 180. So complementary adds to 90, supplementary adds to 180. So if we're looking for angles that are complementary, that means that for angles that are complementary, our target that we're trying to hit, when we add them together, is 90. If we're looking for supplementary, our target that we're looking to hit is 180. If we're looking for them to be neither, our target to hit is anything else in the world except for 90 and 180. So as long as my angles don't add to 90 or don't add to 180, then they're not complementary or supplementary. They're neither. Any other number. Okay? So this angle is 128. So all we need to do is dodge 90 and 180, and we have a pair of angles that are neither. Give me an example of an angle that would go with ABC and not be complementary or supplementary. Give me another angle in the diagram. Say again? FBE. FBE. That is F to B to E. It measures 30. 128 and 30. Add 2. Is the answer 90? No. Is the answer 180? No. So we have hit our target by missing other targets. 158, which is not 90 or 180, so it's neither complementary nor supplementary. Specific targets for what we're adding to. That would be complementary and supplementary. Questions so far? Okay. Next example. I want to start, before we solve for x, I want us to think about what the measure of angle FGH is. Measure of angle FGH. Because it doesn't actually tell you what FGH is, but we should be able to figure it out. Exactly what it measures. Because there are other measurements that it does tell you. And more importantly, you should be able to tell me why. So how many feel confident that they know what FGH, F to G to H? How many are confident that they'd be able to tell me what that measurement is? Okay, a couple of you. For those of you that are able to tell me, see if you can write a sentence explaining how you know. Because it doesn't tell you the measurement. So how do you know that that's the measurement? This is going to be something that we'll eventually say is always true, but a skill that I am going to have us build in the next couple of chapters is to be able to explain to me your reasoning and how you know that a certain measurement is the way it is. For those of you that don't have it, let me give you some hints. Measure of angle MGH. Well, we should be able to figure out what that is. M to G to H. Well, that's a straight line. And we know what a straight line measures. What's a straight line measure? 180. Measure of angle MGF. That's also told to us in the diagram. For those of you writing your explanations, this is kind of the direction that your explanation should take. M to G to F, M to G up through F, gives me that box, and I know what that box means. What does that box mean? 90. That means we have a right angle. And we talked about last week how if I know the entire angle and I know one piece, then I can find the other piece. So the whole thing is 180, and one of the pieces is 90. The only way that can happen is if the other piece is also 90. And we'll talk more about that and say that that's always true when we talk about perpendicular lines. But that means that this angle, F to G to H, is also 90 degrees, which, if I talk about these two angles in the diagram, I put them together and they should make 90. What I would call the angles that when I put them together make 90. Which one was it? It's 90, it's the smaller one, so it should be the one that comes first in the alphabet. It's going to be complementary. Complementary angles. And yes, if you're a stickler for spelling, this is with an E. Complement, meaning that they go together in some way. Okay? A complementary angle is just an angle that's really nice to you and says nice things about you. That's a complement. Complement is, with an E, is saying that they go together. That's why it's with an E and not an I. By definition, if the angles are complementary, then I should be able to take the measures, add them together, and get 90. So what are my measurements? My measurements are 2x plus 3 and a 2x plus 1. I take those, add them together, and I get 90. So I want to remind you again, the equations that you put should be able to be explained or justified from the diagram. You should be able to tell me why you can set up the equation you can set up. Well, I know I can set up this equation because these angles are complementary. And so because those angles are complementary, I know when I add them together, I should get 90. That's why we're adding them together to be 90 and not, say, setting them equal to each other. Nothing that says that those two have to be equal to each other. So we're not going to make them equal to each other. We do know that they add to 90, so we're going to add them to 90. And now we're going to solve. 2x here and a 2x here. We're going to combine everything together on the left side. 2x and a 2x is going to be 4x. 3 and 1 is 4. So I got a 4x plus 4. So I'm going to subtract 4 from both sides. 90 minus 4 is 86. I still have a 4 times x, so I'm going to get rid of it by dividing by 4 on both sides. 86 over 4, this is 43 over 2, which if you want a decimal, that's going to be 21.5. As always, I can plug in and see if my equation is working. See if when I solve this out, it comes out the way it should. So if I've got 21.5, I can take that and put it in for x. Two times x is 21.5 plus 3. Remember, this is 43 over 2. So if I take 43 over 2 and multiply it by 2, I'm just going to get 43. So 43 and 3, that's 46. Same idea here, 21.5 in for x. And this time we have the 43 again, plus 1 this time is 44. And I get 46 and 44. If I add them together, lo and behold, 90. So everything's working the way it's supposed to. Questions on that one before I give you some new words? Today's a lot about vocabulary and new terms. All right, let's keep going. So back to the vocab pages. Our next term, skipping that one. Our next term is about a special type of supplementary angles. For supplementary angles, if we have supplementary angles that are also adjacent, so they're also touching, then the angles are basically just like the angles in the last diagram made a right angle so we could put a box on it. These two angles are going to make 180, and 180 is just going to be a straight line. So because they're a pair of angles that make a line, we're going to call them a linear pair. Linear pair. Pair of angles that make a line. So if you're ever forgetting what the term is, makes a line, so linear pair. And once again, these are pairs of angles. Pairs of angles, so they should be two angles that go together to make a straight line. So these two angles right here make a linear pair, angle 1 and angle 2. Because if I take their measurement, here's angle 1, and here's angle 2. If I trace that arc out together, I should have that 180-degree straight line arc. Same thing over here with angles 3 and angle 4. Take this angle, put it with this angle. Oh, I have a straight line. That's how you can tell if you have a linear pair. So that's linear pair. Pair of angles make a line. And the last one that we're going to talk about is vertical angles. So vertical angles, I'm going to erase this so I can show it again. Vertical angles are angles that are not intersecting or not adjacent in the intersecting lines. Okay? What does that mean? Well, if I have this angle right here, the angle that's not adjacent to it, that's not right next to that angle, well, I have this angle over here on the left. The angle that's right next to it would be the angle on top and also the angle on bottom. So the one that wouldn't be adjacent to it would be the angle on the right. The other way to say it, or the easier way to say it, is that the angles are right across from each other. Directly across from each other, or directly opposite each other. So we have the one on the left and the one on the right. We also have the angles on top and bottom. These angles are also vertical angles. they're also directly across from each other. And so when I trace out the angles, they should make this nice little X shape, because they should be two cross lines, and then pick out the angles that are directly across from each other. So to end with, I want you to kind of check your own vocab knowledge here and try these two. So here's the hint I'll give you, because you should be looking for, on the first diagram, you should be looking for complementary, supplementary, and adjacent. Over here, you should be looking for vertical angles, linear pair. The only thing there should be two pairs of is linear pair. There are two pairs of linear pairs between all these angles. There's only one pair of complementary angles over here, only one pair of supplementary angles, only one pair of adjacent angles, angles that are touching. And there's actually only one pair of vertical angles over here. So I want you to take a couple minutes and write out which angles you think are where.